Right, try something a little bit different down the bottom. First of all, what we're going to do is if we integrate that part there, integrate dy by dx. That's what we did before and we got y, didn't we? Like this is last year. And what we did is we integrate that there. We get 2x squared minus 6x plus c. Is that right?
Yeah.
You happy with that?
Yeah.
Not a pH in that yet. But we can't integrate that, can we? We can't integrate dy by dx. We can't integrate that. What do we integrate? We integrate that with respect to x, don't we? Yeah? Does that make sense? So how did this become this? What we did is we treated that as a fraction and multiplied both sides by our dx. Does that make sense? And so we integrate both sides. When we integrate 1 with respect to y, what we get is our y. So y will equal 2x squared minus 6 plus c. That's my answer. That's my general solution. You understand what I mean by general solution? Because of that plus c. We will have to find the particular solution at some stage. How are we going to find that? By substituting in some points, x and y to solve for c, just like we did last year. The second one there, d squared y over dx squared, how are we going to do that one?
Integrate it twice.
Yeah, integrate it twice. Alright, so let's just integrate x minus 3 with respect to x, which becomes x squared over 2 minus 3x plus c. What am I then going to do?
Integrate that.
Integrate that again with respect to x becomes x cubed over 6 minus 3x squared over 2. What happens to plus c?
C squared. Plus cx.
Plus cx, yeah. Plus k if you want to call it k, whatever you want to call it. But there's my equation.
I got it right and been wrong.
There's my differential solution, so my general solution. Does that seem achievable for us? It's really just going, well, differential equations is a fancy way of saying I've got dy by dx, how do I get y out of that? D squared y over dx squared, how do I get y out of that? Okay? Does that make sense? Happy? So, the next one, well, so we've looked at the general solution. Understanding the particular solution shouldn't be much harder, should it? So we'll solve dy by dx equals 2x, given that y is 6 when x is 2. So in other words, what are we going to do? We're going to say dy equals 2x times dx, so that when I integrate both sides, I'm going to get y equals x squared plus c. You happy with that statement? It is serious, gentlemen. Shush. It is really important you understand that notation, okay? Because we will make it harder, and if you understand it now, then you'll understand it later. Okay? You understand that we are actually integrating 1 with respect to y. Everyone see that? We'll take the one nod as a yes.
Yeah.
So therefore, when x is 2, y is 6. So therefore that's for, so c is therefore 2. So my solution will be y equals x squared plus 2. It's pretty straightforward, isn't it? Mm-hmm. With these simple integration ones, with these simple questions, there are 4 of them there. Okay? We won't spend much time on those, we'll make it a little bit harder shortly. Okay, carry those 4 there, please. Right. How do we do this one? What is dy? What are we going to treat dy by dx as? As fractions, okay. And with fractions we want to put things on one side, put y's on the other one, and put x's on the other. But make sure we've got our dy and our dx are on the top line. So what we're going to do is we're going to go dy equals, x dy equals y dx. Are you happy with what I've just done there?
Yeah.
But I can't integrate here, can I? Can't integrate x with respect to y, can I? So what do I have to do? What do I have to do? Yeah, divide both sides by x and divide both sides by y, which leaves me with 1 over y dy equals 1 over x dx. Now what can I do? Integrate both sides. No, don't give up. What is the integral of 1 over x? Yeah, natural log x. What is the integral of 1 over y? Natural log y. He's in trouble. Stop talking to him.
That's great.
I know. dy, so log y equals log x. Are we missing something here?
Plus C.
Plus c.
What about on the other side?
We don't do that. We just have it on the one side. But remember, gentlemen, stop. Remember, wait. C, I can write that as log k, can't I?
Can you?
Well, because log k is just the number, isn't it? You chuck in your calculator the natural log of 3 and it will give you an answer. If you chuck the natural log of 5, it'll give you a number, just like c was a number. And you guys know that log x plus log k is
Log xk.
log kx, yeah. xk, same thing, kx. If it's k is a number, it's going to be...
That's right.
Sure. All right. Happy with what I've just done so far?
What would be marked wrong though for doing?
Okay. So there's my equation. Have I written my equation as y equals?
No.
How am I going to do that? Tom? I'm going to take each side.
The log.
Oh right, yeah.
Oh yeah, it's just y.
There's a reason I didn't notice it.
Okay. There's my answer. Are you happy with that? What does the k refer to? Just some constant. Okay. And this one here, it goes through 1, 4. 1, 4. So up here, 4 equals k times 1. K is 4. So what's my equation? Y equals 4x. You guys happy with that?
If we didn't have, so if it was log y equals log x plus c,
Yeah.
then would the answer come out as like y equals x plus c to the power of e? Or like how would...
Your answer would be
give us a different
don't know. You just have to remember that, I suppose, at this stage.
yeah, because
First prize. Remember that.
because wouldn't it just give us a different c? Okay.
Well, this is a proportional relationship. You're talking about a plus c, which would be not a proportional relationship to x. It's a constant after x.
Okay.
Okay. So,
Where do you get the natural log of k from?
well, natural log of k, that there is c. C is 10. The natural log of k has to equal 10, so it would be like whatever e to the power of 10 is. Okay. The next one, over here. What are we going to do here?
Same thing. It's the same thing.
Same thing. So you're going to go 1 over y dy equals negative dx. Happy? So when I integrate that, and I integrate that, I get natural log y equals negative x plus c.
Because it's
Oh, negative 1.
negative 1 for a specific term.
You understand why I get the negative there? Yep. So now what I'm going to do, I need y by itself, so I'm going to take the natural, raise everything to the e. Here's my answer. Okay. Happy with that? Happy with that? Okay.
Sure.
The other way you could have done it is gone, well,
He knows all this stuff.
this would be ky. This would be ky. And then you could just go y equals a different k, we'll call it a, e to the negative x. But that's the same thing, isn't it? From your log rules, remember, if this was plus c, if that was plus c and I raise everything to the power of e, then that is going to be y equals e to the negative x plus c. That there is like timesing by e to the c, isn't it? Because when you're multiplying bases, add the indices. You guys all know that x squared times x cubed gives you x to the power of 5. E to the power of negative x times e to the power of c. You're just going to add those powers up. And again, that's just a constant, hence why I can chuck that a in there, which is the same as my left hand side. Bit harder, eh? Can you see with the differential equation stuff coming in?
Yeah.
The notation is going to be quite useful here, eh? Try some of those questions.
Yeah.